It'll just surprise us.
Hi everyone, I'm Mr. Harfinist.
And I'm Mrs. O'Reilly.
And we're going to show you a video today about scientific method. So the objective for you today is that you are going to understand that the scientific method is continuous, reflective, and it's also a problem-solving technique that is used in science and in other real-world applications. The scientific method, depending on what resource you use, is either a 6 or 7 step process. It's a basic process that allows a scientist to uncover facts and basically solve scientific problems, okay? And it is an organized plan for gathering and also communicating data. The steps of the method are: you first make an observation, you ask a question, you will complete background research, develop a hypothesis, experiment or test your hypothesis, analyze the data, and then finally communicate, make a conclusion.
So the first step is observation. We're going to use our senses to observe what's going on around us. Now, the one sense that you usually don't use in science is your taste. But there are other problems in the world outside of the science classroom that you might perceive the observation with your sense of taste. We're going to focus on observations you can make about the leaves in the fall in a place like New England. So you can see to the picture here that you can notice that the leaves have changed when the fall comes in New England. So our first thing is just noticing that they change.
Step 2 is forming a question. So normally in science lab, the observation is already done for you, okay? So based on what you saw though, using your senses, like Ms. O'Reilly said, you usually want to form a how or why question that is going to be able to be solved through some sort of experiment, okay? So we want to make you kind of think on the side is, can you form a question about leaves in New England?
And after you have your question, you'd look into some background research. So you think about what have people already learned about the leaves in the fall in New England? You're going to collect knowledge that you might need to know about the subject in order to complete your experiment where you're going to answer your question. This background research is going to help you develop a hypothesis, which is your next step.
Okay, so the hypothesis is going to be, as you know, an educated prediction that is going to try its best to answer the problem that you developed and the question that you came up with earlier, okay? And since you did your research, you're also going to use what other people have found out about the topic as well as your own prior knowledge about the topic in order to develop this hypothesis. Okay, as said before, it's a proposed answer to your question. And at the beginning, everyone, there's no right or wrong hypothesis. Okay, maybe after experimentation, your hypothesis might be proved wrong, but at the beginning, there is no right or wrong hypothesis. Okay, so we want to now think about using our question about the leaves. What could a hypothesis be? Okay, so there are 2 accepted formats of hypotheses. You probably are more familiar with the bottom one, at least in East Lyme. I know that's what's used in middle school and in 9th and 10th grade. So it's called the if then because statement. Okay, another acceptable form of a hypothesis is I think because. Now, the important part here is most people use the bottom one because when we write scientifically, we usually do it in 3rd person. So, but if you're just thinking out loud, you might say, I think this because, okay? And because is important because it's used to justify what your prediction is.
And then you get to test your hypothesis. This is the fun part. This is the part most people look forward to. This is where you get to conduct your experiment. This would be, where you set up a way to observe how something happens to or to test your hypothesis. It would be repeatable. So what that means is that if you devise your experiment and you write your procedure for your experiment, it's listed in a way that somebody else could take a look at your experiment and repeat it as well. It could also be done repeatedly by you in order to have multiple trials, but the key is that it can be repeated. So you're never going to just test it one time. It's always going to be tested multiple times before your conclusions are accepted as truth. And the goal here is just to test your hypothesis. And you're going to do that by collecting data. And the data that you're going to collect is going to be, didn't we get rid of this slide?
Oh, my turn. I'm sorry.
No, but we got rid of this slide.
Yeah, we did, didn't we? Okay.
This is a slide that you can use as a resource. We're not intending to explain it this way, but you can absolutely use this slide as a resource if you want to pause your video now and use this, but we're going to skip over it because we liked the next, the version that we had created better. So in this one, when you're testing your hypothesis, you're looking at those variables and they can be measured or changed during your experiment. You've got your independent variable, you've got your dependent variable, control, and constant. And these should be terms that are really familiar to you by this point in your science education. The independent variable is what is manipulated during the experiment, sometimes referred to as the manipulated variable. It's the cause. It's causing the change. You might determine that you're going to test something every so many days, every so many weeks. It could be a unit of time. The dependent variable is the effect. It's the data you collect, D for data. It's what you're measuring in your experiment. The control is used for comparison. It's something you already know the answer to. So it's a standard that you can use to compare your results to something you already know the answer to. And constants are all those things that don't change. So if you're using 15 milliliters of water in one of your trials and you use water in every trial, you're going to keep that as a constant. You will always use 15 milliliters of water in every single trial. So think about our experiment. What could the variables be in the fall leaves experiment? And then you're going to collect and analyze the data. So when you collect the data, you're going to use your senses again. So these will be observations. This might be qualitative, it might be quantitative, but you're going to collect all the information and data and you're going to organize it. This will also include the analysis. So this is where you might perform calculations. And through that, you're going to interpret the information you've found or the data you've gathered from your experiment.
And your data can be organized in many different ways. Most likely you're going to use charts or graphs. The important thing to look at on this slide as a reminder is where do we put the variables? The independent variable is always going to be on the x-axis and the dependent variable is always going to be on the y-axis. Okay? And then step 7 is a conclusion. Okay, so you have to ask yourself the following question. Does your data support your hypothesis? And if it's yes, you just made a new scientific discovery. If it's no, you might revise or make a new hypothesis and test again. Now remember, all these experiments are done multiple times. So having one yes, this doesn't mean that, hey, it's all done. Or just getting one no doesn't mean that it's all done. It has to be a reliable and repeatable in multiple hundreds or thousands of times, maybe even millions of times. Some people work for 20, 30 years on these things. Oh, we went down in number for our conclusion. And I'm going to let you do this one.
So the sharing of your results is a summary of your results. You're going to use it to answer your question. So this is kind of like the CER portion. If you are in one of the schools that uses NGSS, which we are, you're going to see that CER, where it's your claim, your evidence, and your reasoning. So your summary of your results, the answer to your question is your claim, and then you would support it with evidence and then provide reasoning. And part of that reasoning would be discussing any possible sources of error and whether or not your data supports or disproves your hypothesis and giving reasons for that. Why does it or does it not support your hypothesis? What did you find that was different?
And then finally, we have to just go back to our original objective. Why do we use the scientific method? Okay, it's a logical way to solve a problem. And like it says, it's in all aspects of life. No matter what, it's not just used in science. You use this every single day. It's a way to share information that can be proved or disproved. And then it's a way to find out new information. Again, the most important part is that it works in all aspects of life.
And so just going back to the beginning, it's an ongoing and reflective technique to solve a problem. So like Mr. Harpin has said, not just for science, but for anything. So thank you. If you have any questions, please let us know.
Bye.
Bye.